In this video, we're going to answer the following learning goal question. How can you determine if two vector equations of a line are going to form parallel, perpendicular, or no relationship between them? Think back to your 8th grade and 9th grade math classes when you learned about lines. If we wanted to determine if lines were parallel or perpendicular, we always had to compare the slopes. Look at this example right here. We have y equals 2x plus 1 graphed and y equals 2x minus 2 graphed. You could see both cases were circling the slope, and we were able to determine in the past that these two lines were parallel based on their slopes. So because their slopes were the same, we knew that the lines were parallel. In vectors, we don't have slopes. However, we do have direction vectors in our equations, which can tell us the direction that the line travels in. If we want to determine if two lines are parallel, perpendicular, the same, or neither, we have to use the direction vectors from the equations to compare them using our flow chart from class to determine the relationship between the two lines. So we'll take a look at a couple of examples dealing with parallel and perpendicular vectors. If you'd like to try these examples on your own and pause the video, you can do that. Just hit play again and the answers will be waiting for you. In the first one, that wants to determine if the following two lines are parallel, perpendicular, the same, or neither. So what I'm going to do first is I'm going to just focus in on the direction vector portion only. So that's this vector that I just circled and the second vector that I also just circled. And I'm going to compare them. I like to write them off to the side just so it's organized out of the equation. So I have 2, -1, 3 for my first vector and 2, 1, -1 for my second vector. If you'd like, you can even label them, call this one A and call this vector B, if it helps you keep even more organized. I can see just by looking at them, since they're not scalars of each other, that they're not parallel. So I have to continue on in my checklist to see if the dot product would be equal to 0. So I'm going to check the dot product of A dot B. Don't forget your symbols when you write vectors. So doing the dot product, I can see that I get 2 times 2 plus -1 times 1 plus 3 times -1. And when I simplify, that becomes 4 minus 1 minus 3. 4 minus 1 minus 3 is equal to 0. Therefore, I know that the lines are perpendicular because their dot products equal to 0. If you'd like to try the next example and pause it, feel free to do that. And again, I'll have the answer worked out for you when you come back in. The line through the point 2, 0, -1 is parallel to a vector -3 plus 3i plus j minus k. They wants to determine the equation of a line that describes this setup. So remember, in your equation of a line from a vector, we know that r is equal to vector a, your position vector, plus t times your direction vector. So I need two things. I need my position vector and I need my direction vector. My position vector comes from the given point, 2, 0, -1. So I'm actually just going to rewrite that as a vector and fill it in. Plus t, you don't want to forget that detail. And now I need my direction vector. Well, since this line that we're writing an equation for is parallel to this vector, -3i plus j minus k, all I have to do is take that vector and put it into my equation, because parallel vectors should be equivalent with a scale factor, which is why we have t to account for that. So this vector, -3ij minus k, will fill right in for my position vector, my direction vector rather, and my final equation is written there, as you can see. One more question where we're determining if the lines are parallel, perpendicular, or neither. So one more time I'll say it. We want to look at the direction vector first. Here we have 3, 3, 1. We'll look at the other direction vector and compare them. So I like to rewrite them separate first to see if I see any relationships right away. 3, 3, 1 compared with 6, 6, 2. And what you might be noticing now is that this 6, 6, 2 vector is 2 times bigger than our 3, 3, 1 vector. So because it's 2 times bigger, they're scalar multiples of each other. And when we have two vectors that are scalar multiples of each other, we say that they are parallel. So these are parallel lines. And in our next class, we're going to see if we can check to see if they're not just parallel, if they're actually the same line. So tomorrow, we check to see if they're the same. Thank you for watching this video. If you have any questions, let us know at the start of class tomorrow and we'll give you a check-in just to make sure you understand all the different pieces that went into this. Have a great day. Bye.